So our group number is six, and me and our group member are presenting topic audio signal processing, which is part of signal processing ISC2. So my name is Vivek Patil. Uh, so let's start from what is an audio signal. So an audio signal is a representation of sound typically in the form of time-varying voltage or pressure wave. Digital audio signals are sampled and quantized representation of continuous sound with key properties such as sampling rate (fs), the number of samples per second measured in hertz. Common values are 44.1 kHz, which is CD quality, and 48 kHz. Second property is amplitude. Amplitude represents loudness of sound at given point in time. The third property is frequency. The frequency means the number of oscillations, that is cycles per second, measured in hertz. This determines the pitch of the sound. So, so why we are using the MATLAB for audio processing? So it has six advantages to use for audio signal processing. First is powerful toolbox. Second is efficient data handling. Third is real-time processing. Fourth is extensive libraries. Fifth is integration with AI. And sixth is cross-platform compatibility. So we can perform some operation on audio signal using MATLAB. MATLAB has inbuilt function to do the search manipulations on sound. The first is speeding up or slowing down the audio. We can increase the speed of sound or decrease the speed of sound by using some functions. Second is we can increase or decrease the volume by using inbuilt MATLAB function. Third is echo effect. By changing some delays in sound, we can add the echo effect in sound. Fourth is audio compression. We can compress the audio file in MATLAB.
Next is MATLAB program overview. The objective of this MATLAB program is record voice input, analyze the signal in both time and frequency domain. Next, frequency noise using a low pass filter. The step one is recording voice input. Command one is fs is equals to 44,100. This sets the sampling frequency to 44.1 kilohertz, which is the standard audio recording. Then next command is recobj is equals to audio recorder in bracket fs comma 16 comma 1. This creates the audio recorder object with a 44.1 kilohertz sampling frequency, 16-bit resolution, and one channel for mono ordering. Then third command is DISP in bracket start speaking. This command displays a message to prompt to start speaking. And next command is recording blocking in bracket recobj comma 4. This command is used for records voice input for 4 seconds and blocks the further code execution until the recording is complete. Then next command is DISP in bracket recording complete. This notifies the user that recording is done. Further next step is retrieving recorded data. Then command voice signal is equals to get audio data in bracket recobj. This command retrieves the recorded audio data and stores it in the variable voice signal. Then next step is creating a time axis for plotting. Command t is equals to in bracket 0 length in bracket voice signal dash 1 upon fs. This creates the time axis vector t, which is used to plot the voice signal in the time domain. And next step is plotting the time domain signal. The command figure is used to open a new figure window for plotting. Then command subplot 3 comma 1 comma 1. This command creates the first subplot in a 3 row comma one row layout. Then next command is plot in bracket t comma voice signal. This command plot the voice signal amplitude over the time. Then next command is title in bracket original voice signal in bracket voice domain. These commands add the title original voice signal time domain in the into the plot. Then next command is x label. X label the labels the x-axis time s, and command y label is labels the y-axis as amplitude. Then next step is analyzing the frequency domain for a transform. Then the next command is n is equals to length in bracket voice signal. These commands find the total number of samples in voice signal for the frequency domain analysis. And next command is f is equals to in bracket 0 n dash 1 into fs divided by 9. Creates this command creates the frequency axis f from 0 hertz to the Nyquist frequency, which is half of the sampling rate. Then next command is voice FFT. Voice FFT is equals to FFT in bracket voice signal. This commands computes the fast Fourier transform FFT of the voice signal to convert it from time domain to the frequency domain. And next step is plotting frequency domain signal. Command subplot 3, 1, 2 creates this second subplot in the 3 row 1 column layout. Then command plot in bracket in bracket 1 floor n divided by 2 comma abs in bracket was fft in bracket 1 uh, floor in bracket n divided by 2 slash n. This commands plot the magnitude of FFT, the frequency component of the from 0 to half of the sampling rate. And next command is title original voice signal frequency domain. This commands adds the title original signal frequency domain to the plot. Then command X label and command Y label will labels x-axis frequency in hertz and labels the y-axis as a magnitude respectively.
Now the next command will be to design the low pass filter. So the command is fc equals to 1000 which will set a cutoff frequency of 1000 hertz for the filter. The second command is b comma a equals to butter 6 comma fc by fs by 2 low. This will this this is a second function, and that will design a sixth order low pass Butterworth filter with cutoff frequency normalized by the Nyquist frequency. The next four lines command, that is subplot 3 comma 1 comma 3 plot t comma filtered signal, will apply the designed LPF to the recorded voice signal, and it will produce a filtered version. The title is filtered voice signal in time domain. X label and label represents the x-axis as time signal and y-axis as amplitude. The next operation will plot a filtered signal in the frequency domain. It has the instructions are figure filtered FFT equals to FFT filtered signal, plot f comma f bracket 1 is to floor n by 2 comma abs filtered FFT 1 is to floor n by 2 by n. The title is filtered voice signal, and the x and y axis is frequency versus magnitude. Now the final command will be display playing filtered voice signal and sound filtered signal comma fs. This will play the filtered voice signal at the last. Now let me start by running the program. So here I run the program. Good morning. Hello, my name is Mudit Deodhar. Okay, so this recorded my voice for 4 seconds. So this is the original voice signal graph in which is time versus amplitude. This one is the original voice signal that has frequency versus magnitude. This is the filtered voice signal graph in time domain, that is time versus amplitude. And this is the filtered voice signal in frequency domain graph, in which it is frequency versus magnitude. Thank you so much.